It's too late for apologies. New James Webb Telescope discovery just shakes up Einstein's theory. What if Einstein was wrong all along? For over a century, his theories have shaped the way we understand time, space, and gravity. But now, something has changed. The James Webb Space Telescope, humanity's most advanced eye in the sky, just spotted something that doesn't fit. And it's not a small detail. It's the kind of discovery that could tear open the fabric of modern physics. Scientists are stunned. Equations aren't adding up. And the deeper they look, the more unsettling the truth becomes. Because what Webb just revealed might flip Einstein's legacy upside down. It all started with something scientists call the Hubble tension. For years, astronomers have argued over how fast the universe is expanding. There are two main ways to measure it. One looks at how nearby galaxies move away from us, based on observations of stars and supernovae. The other measures the afterglow of the Big Bang itself, the cosmic microwave background. Both methods are precise, but strangely, they don't match. The numbers should line up, yet they don't. It's like two clocks measuring the same moment and disagreeing by millions of years. When the James Webb Space Telescope launched, scientists hoped it would be the final word. Its infrared vision is sharper than anything we've ever used to peer into deep space. And with that power, Webb took aim at distant galaxies, measuring their light, movement, and position in time. But instead of resolving the issue, Webb confirmed it. The universe is expanding faster than it should be. Faster than Einstein's equations allow. This wasn't a fluke. It wasn't a miscalculation. It was a wake-up call. Now the tension isn't just academic. It's foundational. It's forcing physicists to reconsider whether dark energy, gravity, or even time itself works the way we thought. And if the basic structure of the universe is unraveling, then everything built on top of it, relativity, cosmology, particle physics, could be in danger. The Webb telescope didn't just sharpen our vision. It cracked open a problem no one's been able to fix. As if the expansion mystery wasn't enough, James Webb uncovered something even stranger. Something that shook scientists to their core. While scanning deep into the early universe, Webb spotted galaxies forming way too early. We're talking just 300 million years after the Big Bang. Barely a blink in cosmic time. But these weren't small, faint galaxies. They were massive, bright, and fully formed, almost like our Milky Way, only billions of years ahead of schedule. According to everything we thought we knew, galaxies this large should have taken billions of years to grow. The laws of physics, the models of cosmic evolution, they all say this kind of rapid growth shouldn't be possible. Yet there it was, staring back through Webb's lens. Ancient giants shining when they shouldn't even exist. Some scientists began whispering the unthinkable. Maybe the Big Bang timeline isn't what we thought. Maybe gravity behaved differently back then. Or maybe, just maybe, the very framework of our cosmology is broken. Theories like modified gravity and alternative universes started creeping back into the conversation. Because if galaxies can break the rules this early on, it means we don't really know when structure began, or how. And just when researchers tried to make sense of that, the universe threw another curveball. Just when scientists thought things couldn't get weirder, Webb zoomed in on a quasar, a bright, distant object powered by a supermassive black hole. But what it revealed wasn't just another deep space light show. It was a phenomenon Einstein himself predicted, yet never imagined we'd witness like this. The light from that single quasar had split into 6 distinct images. Not 2, not 3, 6, all from one source. How? The answer lies in gravitational lensing, where massive objects, like galaxies, bend and distort light as it passes by them. It's like a cosmic funhouse mirror, warping everything behind it. But the paths the light took, twisting, bending, zigzagging through space, were so complex, it left researchers stunned. Einstein's theory of general relativity could explain some of this, but not all. The arrangement was too intricate, too unexpected, almost as if space itself was playing tricks on us. More questions followed. Were we seeing some new form of lensing? Could there be unknown structures, like invisible mass or exotic matter, bending light in ways we don't yet understand? And if light can take such strange routes across the cosmos, what does that say about the very shape of the universe? But Webb wasn't finished. Because the next revelation, it wasn't about light, it was about spin, and it was even harder to explain. In a universe that's supposed to be random and symmetrical, James Webb found something that shouldn't exist, a pattern. Scientists analyzing galaxy spins made a baffling discovery. An unusually high number of galaxies appear to spin in the same direction. Specifically, more than 2/3 seem to rotate clockwise, as if the universe itself had a preferred twist. That might sound harmless, just a cosmic coincidence, but it's not. According to the standard model of cosmology, there should be no bias. Galaxies should spin left or right with equal probability, like a coin toss. Instead, Webb's findings suggest something far more organized, and possibly intentional. Some physicists now wonder if the entire universe is rotating on a massive, unimaginable scale. One bold theory suggests we might actually be living inside a giant spinning black hole. The idea sounds like science fiction, but it's rooted in serious mathematical models, and the galaxy spin alignment gives it fuel. If true, it means our whole understanding of space and time could be based on a false assumption. Einstein's theories never accounted for this kind of structure on a universal scale. And if the cosmos does have a hidden spin, it would rewrite the rules of gravity, inertia, and possibly even time itself. But this wasn't just a wild theory on paper. More and more data kept piling up. Data that pointed in one direction. Something in Einstein's model wasn't holding up under pressure. With each new anomaly, the cracks in our current model of the universe are getting harder to ignore. The expansion mismatch, the impossibly early galaxies, the zigzagging light, the spinning galaxies. Each one could have been a fluke on its own, but together they form a pattern too loud to dismiss. And now, scientists are asking a question once considered taboo. What if Einstein's theories, while brilliant, are incomplete? Alternative models are stepping into the spotlight. Modified Newtonian dynamics, or MOND, is gaining traction again, suggesting gravity behaves differently at cosmic scales. Others are revisiting ideas like variable dark energy or hidden dimensions. Some physicists are even exploring whether time itself might not flow in one direction, or whether the Big Bang was just one event in an endless loop of cosmic cycles. It's not about discrediting Einstein. It's about expanding on what he started. After all, even he once admitted that his equations couldn't explain everything. But now, with the Webb telescope revealing more than ever before, we might finally be standing at the edge of a new era in physics. One where questions that were once ridiculed are now the only ones worth asking. And the biggest question of all? If the foundation of modern physics is shifting, what's coming next? This isn't just some theoretical debate between scientists in lab coats. If the James Webb Telescope continues to find evidence that contradicts our most trusted models, then we're not just tweaking equations. We're rethinking the very rules of reality. Everything from how stars form to how time flows, how black holes work, and even how the universe ends could change. And with each new observation, the need for a new theory grows stronger. We've reached a tipping point. The discoveries aren't slowing down. They're accelerating. Every deep-scan web could expose another piece of the puzzle we didn't know was missing. And with that, the door opens wider to ideas we once considered fringe. Cyclical time, alternate universes, cosmic rotation, even the breakdown of gravity itself at the largest scales. Why does this matter now? Because for the first time in generations, we're not just adding to our understanding of the universe, we might be replacing it. And what comes next could challenge not just our science, but our place in the cosmos. The next breakthrough could be the one that forces us to rewrite the textbooks, redraw the maps of space and time, and rethink everything we thought we knew. So, what did we just uncover? The James Webb Telescope didn't just confirm old ideas. It shattered expectations. It exposed a universe expanding faster than Einstein predicted. It found galaxies too massive, too early to explain. It revealed light bending in ways we didn't foresee, and galaxies spinning with a strange, consistent bias. Each piece alone is puzzling. Together, they form a loud message. Our current model of the universe isn't enough. For decades, Einstein's theories stood as the foundation of modern physics. But now, that foundation is cracking, and what lies beneath is still unknown. Some will say it's too soon to panic. Others believe we're witnessing the birth of a new era in science. But one thing is clear. The universe isn't playing by the rules we wrote, and that means everything, from dark matter to the nature of time, could be up for revision. Is it too late for apologies to Einstein? Maybe. Or maybe he saw this coming all along. Either way, the James Webb Telescope has just opened the next chapter of cosmic discovery. And something tells me the wildest revelations are still ahead.